Chapter 1: The Psychology of Thinking. Thinking is so central to the human experience that it has been described as the essence of being. We are all familiar with the phrase, je pense donc je suis, or I think therefore I am. This comes, of course, from Descartes' Discourse on Methods, 1637, and underscores what is so crucial and compelling about the study of thinking. Humans, like other animals, behave, learn, respond, communicate, and remember, but humans also think. We can discover something new by thinking about it. We can solve problems in the mind, visualize solutions, and arrive at an important decision by thinking. We can be aware of our own thoughts and aware of the consequences of our actions and behaviors. This book is about the psychology of thinking. That might sound redundant, given that psychology is often defined as the study of the mind or of mental activity. In other words, if psychology is not about thinking, what else can it be about? Psychology is a very broad field, encompassing everything from the study of neurotransmitters and basic neuroanatomy to the study of learning and memory to the understanding of mental health and the study of group behavior. This book is concerned with the study and understanding of the thought process. Thinking is usually studied within the broader field of cognition. Cognitive psychology has traditionally been defined as the study of information processing and behavior. This encompasses everything from basic attention and perception to memory, concepts, and thinking. As a topic within the study of cognitive psychology, the psychology of thinking is concerned with complex mental behaviors such as problem solving, reasoning, decision making, and becoming an expert. A good understanding of basic cognition is very useful in understanding the psychology of thinking, but it is not necessary. In other words, if you are reading this book as part of a course on thinking, a course on reasoning and decision making, or even a business or marketing course, and you have already taken a course on cognition, then you may find some helpful overlap in some of the topics covered. But if you have not taken a course on cognition, I do not think you will have any additional difficulty. I have tried to write this text so that it builds on prior knowledge, although that knowledge is not strictly necessary, and you can enjoy and use this book without any prior formal study in cognition. In this first chapter, I want to describe what thinking is, and what it is not, for the purposes of this book. I want to consider several examples of thinking, and several challenges to clear thinking. I will also describe some of the ways in which thinking has traditionally been studied. Objectives. This chapter covers an introduction to the psychology of thinking, some of the history of the field, and the current approaches for the study of thinking. By the end of the chapter, you should be familiar with a definition of the thinking process and how cognition and thinking are related, and what kinds of mental activity are considered to be part of the thinking process. Descriptions of different kinds of thinking, challenges to the thinking process, like multitasking or missing information, theoretical approaches to the study of thinking, such as Gestalt theory, the cognitive approach, and the dual process theory. What is thinking? A basic description. Thinking is mental activity, but it is not just any mental activity, or rather, thinking and mental activity are not synonymous. For example, basic visual perception, memory consolidation, and coordination of sensory motor activity are all very sophisticated mental activities, but these kinds of behaviors are not usually considered to be thinking. Thinking is a very specific subset of mental activity that involves working with mental representations, planning and executing behaviors, and the coordination of cognitive resources. For example, solving an algebra problem, analyzing the themes in a film, discussing the prospects for your favorite sports team, or making a split-second decision about which route to take when a road is closed are all examples of thinking. Some of these are examples of fast thinking, intuitive judgments, and others are examples of slower thinking, reasoning, and analyzing. We'll discuss these two kinds of thinking later in this chapter. Daydreaming, fantasy, depressive thoughts, and anxious ruminations are all also examples of thinking, but are less focused and sometimes less productive. In this book, I will deal primarily with thinking as a cognitive phenomenon and spend less time considering the contents of unstructured thought or the clinical ramifications of thoughts that are difficult to control. Different kinds of thinking. Thinking can be divided up in many ways, including divisions based on content, effort, the desired outcome, underlying cognitive processes, and function. These kinds of divisions are intuitive, but also allow researchers to study thinking at different levels. For example, we must make a distinction between the kind of thought that one engages in when solving an introductory physics problem and the kind of thought that one engages in when catching a fly ball in baseball. For readers not immediately familiar with fly balls, this is a ball that is hit with a high arc, which can easily exceed 30 meters, 100 feet. Catching one is fairly easy with practice and involves being able to predict exactly where the ball will land and placing oneself in that location. Solving a physics problem and catching a fly ball both require attention. Solving a physics problem and catching a fly ball both have a measurable outcome, passing the exam or catching the ball, and both are essentially physics problems. But solving an introductory physics problem requires sustained attention, the recall and generation of learned facts, the conscious application of those facts, and the ability to engage in some kind of explicit monitoring of the behavior. This is a conscious and effortful process, even if the solver in question has some experience with physics problems. Catching a fly ball, on the other hand, is a process that often defies verbal description. It is intuitive and does not seem to rely on the recall of facts, but rather on the replay of hand-eye coordination routines. The physics calculations needed to predict where the ball will land are complicated and require information that the person catching the ball will not have, such as the exit velocity when the ball was struck and the launch angle. Catching a fly ball and solving a basic physics problem are both examples of complex thinking, and yet they differ in terms of what psychological processes are active during the execution. A thorough understanding of the psychology of thinking requires being able to differentiate between these two kinds of thought processes, the cognitive processes that underlie them, and to be able to have an adequate theoretical description of thinking that encompasses both kinds of thinking. Consider another example: the thinking processes behind a game of chess. Playing chess requires the coordination of several cognitive processes and behaviors. One must have sufficient knowledge of the rules, a good recall for the rules, and be able to apply them. Playing chess, and especially playing chess effectively, also involve recall for common chess positions and recall of previously played games of chess. Playing chess effectively also involves thinking ahead, thinking about what your opponent might do, and developing a strategy for how to react based on what you think the other player will do. This second set of behaviors involves what is known as a theory of mind, which means being able to consider the contents of another person's thoughts. Playing chess can be contrasted with playing a visually oriented video game. Many games, especially the simple physics puzzle games found on mobile platforms, such as the Angry Birds type games, place much less emphasis on rule acquisition and retrieval of rules for memory, and place a greater premium on procedurally learned motor responses. As with the previous example, catching fly balls versus solving physics problems, the first behavior is a conscious and effortful process, whereas the second behavior is an intuitive and procedural process that defies verbal description. Interestingly, both rely on some degree of retrieved memories. In the chapter on expertise in this text, we will discuss at length the degree to which expert chess players rely on the rapid retrieval of previously learned patterns. This may share some overlap with the kind of rapid retrieval of the previously learned motor responses involved in many visually oriented video games. So although these two kinds of thinking are quite different in many ways and solve different problems, there are shared underlying mechanisms, in this case, the retrieval of prior instances from memory. We could go with many other examples, dissecting them to consider what principles of thought and cognition are involved. Writing a paper for a course requires reading and retaining new ideas, considering more than one idea simultaneously, being able to examine the parallels and analogies among ideas, and also being able to make use of basic linguistic process to communicate the idea. Learning to play a short piece on the piano involves the mapping of written notes to motor action, the focus of attention on the sound of the piece, the coordination of several different motor behaviors. Diagnosing patients involves attending to symptoms, comparing the similarity of the observed symptoms to memory representations of previously seen patients. Looking over many of these examples, we start to recognize commonalities, focusing attention, making judgments about similarity, considering several ideas simultaneously. These common attributes will eventually become the objects of study for understanding the psychology of thinking. Challenges to the thinking process. Thinking occurs on many levels and, as described above, different actions require different levels of thought. In fact, most of the time we either arrive at correct decisions or we arrive at decisions for which there was little cost to indirect decision. Furthermore, many researchers argue that humans are quite capable of predicting and judging information, even in the face of incomplete and sparse information. For example, a recent study by Tom Griffiths and Joshua Tenenbaum looked at people's ability to make quick judgments about things they were not experts in, such as how much money a movie might make, a person's lifespan given a quick summary, or how long it takes to bake a cake. They found that most people were able to make predictions that fell closely in line with statistical models of optimal outcome. In other words, people often make really good judgments and predictions even if they are not exactly sure about how or why they are doing it. A possible explanation is that people are very efficient at using their existing knowledge, memory, and understanding to fill in gaps and make quick predictions. But if you have ever arrived at the wrong conclusion, solved a problem incorrectly, or made a bad decision, you've probably realized that thinking can sometimes be a challenge. We make mistakes. Sometimes we have to think about too many things at once, or we do not have all the information we require to arrive at a good decision. The section below considers some of the primary challenges that we face. We will consider many more thinking challenges later in this book. Multitasking. Multitasking is both commonplace and misunderstood. We know that multitasking refers to being able to do more than one thing at a time, like reading and listening to music, talking while cooking, checking Facebook during a lecture, texting and driving, etc. The human brain and mind are designed to be able to divide attention and resources among several input and output channels. What is challenging about understanding multitasking is that most people are aware that it often occurs with some cost to behaviors, but at the same time they often assume that it is a necessary action, a positive skill, or both. It would not be uncommon to hear someone claim to be good at multitasking. But is it really possible to be good at multitasking? Current research suggests that there is nearly always a cost, and that this cost may even last beyond the multitasking event. For example, a study by Ophir et al. Created a questionnaire that allowed them to measure light, medium, and heavy medium multitaskers. In this case, medium multitasking refers to using more than one media device or following more than one media stream at the same time. Examples might include studying while watching a show on Netflix, taking notes in class while checking a Twitter feed, or listening to music while reading. These examples are common. They are things that we all probably do from time to time. However, heavy medium multitaskers were those who were more than one full standard deviation above the average score on the questionnaire. Participants in the experiment were asked to engage in a number of tasks that required them to switch quickly between responses and detect targets in the presence of distractors. If people were really good at multitasking, they might be expected to do well at a task like this because good performance relies on the ability to switch quickly and screen out irrelevant information. This was not the finding, however. Being a heavy media multitasker did not seem to predict a better performance on these cognitive tasks. In fact, the researchers found the opposite pattern, that heavy or chronic media multitaskers performed worse on a test of task switching ability, likely due to a reduced ability to filter out interference from the irrelevant task set. In other words, the very people who were the heaviest multitaskers and who should have been good at multitasking were not really very good at all, and they actually performed worse on a test of actual multitasking. One possible explanation for this counterintuitive result is that heavy medium multitaskers have adopted an attentional style that results in greater distractibility. In other words, instead of being better at selectively attending and screening out, heavy medium multitaskers were worse because they were constantly switching and being distracted. This does not mean that medium multitaskers will suffer on all tasks, but it does suggest that multitasking may not always be a benefit. Theory in the real world. One of the most prevalent things in many of our lives is a smartphone. For those of us that use or rely on a smartphone, we know the challenges that it presents and the relative costs and benefits. Without getting into a long list of features and aspects of phones, consider what the smartphone can do to help or hurt the thinking process. The positive aspects are pretty clear. People use their phones for communication, texting, as cameras, as clocks, as weather stations, and as a newspaper. As long as the device is connected to a network, users have access to more knowledge than has ever been possible before. One of the most likely negative effects of having a smartphone is multitasking. Our cognitive systems are designed to process multiple channels of information, but there is almost always a cost. As you are reading this now, you may have a smartphone. You may have even thought to look at it right now to see if any text message, emails, etc. have arrived. Consider another dimension to smartphone multitasking. Not only do people find themselves splitting their attention between several things, for example, taking notes, listening to a lecture, and checking a smartphone, but they may also find themselves spending energy actively ignoring one of these things. That is, the smartphone uses cognitive resources when you are checking it or responding to a text, but it also uses cognitive resources when you try to ignore it. As an example, several years ago, I was in the middle of a lecture and my smartphone buzzed because of an incoming text message. Only a handful of people send me text messages, my wife, my kids, etc., and they would not text me during a class. But this happened to occur at a time when a member of my extended family was in the hospital with a serious condition. The result was that I simply could not concentrate on the lecture and had to stop to read the text. Everything was fine. The point is that the process of trying to inhibit the urge to read the text message was draining on my cognitive resources. A recent study by Adrian Ward and colleagues tested this idea and found that just having your phone near you can interfere with some cognitive processing. They asked 448 undergraduate volunteers to come into the lab and participate in a series of psychological tests. Participants were randomly assigned to one of three conditions: desk, pocket bag, or other room. People in the other room condition left all of their belongings in the lobby before entering the testing room. People in the desk condition left most of their belongings in the lobby, but took their phones into the testing room and were instructed to place them face down on the desk. Participants in the pocket bag condition carried all of their belongings into the testing room with them and kept their phones wherever they naturally would, usually a pocket or bag. Phones were kept on silent. The participants in all three groups then engaged in a test of working memory and executive function called the Operation Span task, in which they had to work out basic math tests and keep track of letters. You can run the task yourself at website, as well as the Raven's Progressive Matrices task, which is a test of fluid intelligence. The results were striking. In both cases, Having the phone nearby significantly reduced participant performance on these tasks. This is not good news for someone like me, who always seems to have their phone close at hand. Heuristics and biases. Another potential challenge to the thinking process is the tendency for humans to rely on heuristics and show biases when making decisions. A heuristic is generally defined as a cognitive shortcut. When people use heuristics, they are relying on knowledge to solve a problem or arrive at a solution rather than a more active thought process. Heuristics are not just guesses, though. They provide reasonably good solutions or decision outcomes based on personal knowledge. The more extensive the person's knowledge is, the more likely the heuristic will be able to provide the correct answer or optimal decision. The advantage of a heuristic is that the solution can be generated quickly. Heuristics are faster than working through a problem, and they are usually correct. As an example, imagine that you are the designated driver for an evening out with your friends. You want to pick everyone up and drive to your destination in the shortest way possible. One solution to this problem would be to map out the driving distance from your home to the home of each of your friends, and from each friend's home to the homes of your other friends, and then from each friend's home to your destination. You would then compare every possible permutation and see which of these produces the actual shortest distance. This algorithm might be time intensive, but it is guaranteed to find the correct solution. However, in practice, you would probably not carry out this set of calculations. You would rely on a heuristic that takes advantage of your general knowledge of the area and choose a route that seemed to minimize the distances. This would probably also arrive at the same answer, the shortest route. The key difference is that the heuristic only really works well if you have a rich knowledge base to draw upon when making the inferences and generating solutions. And as will be discussed in subsequent chapters, although heuristics might be more efficient because they are based on specific knowledge, they may produce an incorrect solution if the underlying knowledge base contains false or incomplete information. The reliance on heuristics has long been thought to be a source of cognitive errors, although more recent work assumes that heuristics are a sign of adaptive cognition. Both of these perspectives will be covered in later chapters on problem solving and decision making. Incomplete or incorrect knowledge. It may seem fairly obvious, but a major source of errors in thinking is an imperfect or incorrect knowledge base. In a sense, this underlies many of the cognitive heuristic errors as well. Consider a very straightforward example. A student is struggling to solve an algebra problem for her homework. If she remembers the correct algorithm or correct example, the solution should eventually come to her. However, if she remembers the wrong algorithm, an incorrect example, or can't remember an example at all, the problem will be much more difficult to solve. In general, thinking is more difficult when you are thinking about something that is in an unfamiliar domain. Thinking is more difficult when you are trying to solve a problem that is really novel. Later in this text, in the chapter on problem solving, we will discuss general strategies for solving problems in cases where the knowledge base is incomplete. At the other extreme, experts are characterized by a very rich and extensive knowledge base. This rich and extensive knowledge base helps experts to solve problems more quickly, make diagnoses more quickly, and make optimal decisions more efficiently. There are many other examples of how incorrect or incomplete knowledge can affect the thinking process. For example, the general tendency to make judgments and decisions on the basis of information that is available in memory is known as the availability heuristic. In other words, people tend to make decisions on the basis of the information they have immediately available in their consciousness or immediately retrievable from memory. More often than not, this heuristic will lead to correct decisions. After all, we have evolved to trust our own memories. However, events that are perceived as being more frequent because of high salience or recency will skew our judgments. People routinely overestimate the likelihood of serious injury due to things like shark attacks, terrorist attacks, airplane disasters. These events are tragic when they occur, but still occur with very low frequency. However, often the tragic nature of these events leaves them more salient in memory over other mundane events of higher frequency, such as vehicle accidents. As a result, our memory about low and high frequency events is skewed, and in the skewed memory representation results in a bias. This bias results in overestimating the occurrence of low frequency events. Later in this book, we will cover other types of cognitive error and bias. In many ways, these errors are a major source of insight into the thinking process. It is also important to note that despite these errors, most people arrive at reasonable conclusions and make good decisions. Herbert Simon, the influential cognitive scientist and artificial intelligence researcher, refers to this as satisficing. Simon argues that a cognitive system designed to seek optimal performance is likely to be impossible and certainly undesirable for most applications. If optimality is difficult or impossible to achieve, then a cognitive system designed to seek optimal performance will fail. A more adaptive approach, largely describing human cognitive abilities, is one which seeks a good enough outcome, but not a perfect outcome. Theoretical approaches to the study of thinking. I started this chapter with a reference to Descartes. Interest in understanding thinking goes back much farther than that. Philosophers, theologians, psychologists, and physicians, as well as the average person, have all spent time trying to understand how we think, what we think about, and why we have the thoughts that we do. Since this text is on the psychology of thinking, we will not spend much time discussing the earlier, less psychological accounts. In addition, because this is a book from the cognitive psychological tradition, we will start with early work that directly influenced the cognitive tradition. This does not mean to undermine or negate any of the important work on the role of unconscious motivations in thinking that are associated with the psychoanalytic approach developed by Sigmund Freud. One could easily argue that Freud's work was influential in bringing about a consideration of the complexity of human thought. Furthermore, as we consider what is sometimes known as the dual process approach, it may be worth noting some higher order similarities between the Freudian model of personality, with an emphasis on conflict between fast, intuitive behaviors and higher order cognitive processes to keep them in check, and the role of a fast, intuitive system versus a slower, deliberative system in thinking and cognition. I am not suggesting that the dual process approach to cognition is analogous to Freudian theories, but rather that both are attempting to describe the same underlying systems of thought. The Gestalt approach. As discussed above, it is important to understand some of the historical and theoretical developments that led up to our current understanding of human thought. One of the more well-known of these earlier approaches is the Gestalt approach. This was one of the primary approaches to the study of thinking in the early part of the 20th century, so the early part of the 1900s. The Gestalt approach arose in Germany and was a counter to the structuralist approaches of the same era. Most of us know about the Gestalt laws of grouping. These are perceptual laws that all center on the idea that humans are biased to perceive whole objects rather than parts. For example, the law of proximity states that features or figures that are near each other will tend to be perceived as belonging to a common object. Likewise, the law of similarity states that elements or features in a group of objects are perceived as belonging together if the objects are similar to each other. Note that these laws are primarily descriptive, and although they serve as good rules of thumb for describing our perceptual preferences, they have generally been criticized for lacking scientific rigor and for failing to provide sufficient explanatory power. Figure 1.1 shows some basic examples. Although most of these are simple perceptual grouping laws, these laws also suggest a reliance on whole object perception. By this view, the mind is not a blank slate, but is designed in such a way as to process information and deal with representations. processed information and representations are the objects of study in the psychology of thinking. And of course, many of the ideas do live on in the contemporary principles of aesthetics and design. Figure 1.1, an example of some of the Gestalt laws of grouping. According to the Gestalt view, we tend to perceive whole objects and show a preference for grouping similar things together. Examples of Gestalt laws: proximity, similarity, closure, common fate, motion, good continuation. While the perceptual laws of Gestalt psychology have mostly been superseded by more sophisticated theoretical approaches, Gestalt psychology also emphasized several approaches to thinking and problem solving which influence subsequent theories of thinking. For example, Max Wertheimer, who was one of the founders of the Gestalt school, considered two broadly defined kinds of thinking: productive thinking and reproductive thinking. An example of productive thinking is solving a problem with an insight. Insight problems, as we will discuss later in the chapter on problem solving, are bursts of ideas, clarity, or correct solutions that often seem to arrive suddenly in the mind. For example, if you are solving a crossword puzzle, you might struggle with a clue and put that one aside while you move on to another clue. Sometimes, the answer to the first clue might seem to arrive suddenly and may even be accompanied with a feeling of satisfaction and relief. On the other hand, reproductive thinking and problem solving refers to problem solving by remembered examples and remembered rules. Although these Gestalt principles of productive and reproductive thinking do not map directly onto current theories, they have influenced more contemporary ideas of algorithmic and heuristic problem solving. It might be tempting to regard the Gestalt ideas as an artifact of a less sophisticated time in psychology, but I think that would be a mistake. These ideas do continue to resonate even within our current attempts to understand the thinking process. The cognitive approach. Most psychology students have read the history of the so-called cognitive revolution. This refers to the transition of experimental psychology from a scientific approach that emphasized behaviorism and the laws of learning to the scientific approach that emphasized cognition, mental representations, and information processing. This revolution did not happen overnight or even over the course of a few years, but there certainly was a major paradigm shift in the field. Whereas in the 1930s and 1940s, a great many university research laboratories would have been designed to study behavior as a result of learning stimuli response associations. Later on in the 1950s and 1960s, many university psychology labs were investigating memory as an internal representation, problem solving as a cognitive process, and thinking. Most of the topics in this text, and indeed the study of psychology of thinking, were studied and framed within the cognitive tradition. One of the most influential texts from that era was A Study of Thinking by Bruner et al., published in 1956. This book helped to usher in the modern era of information processing accounts of thinking. Its general thesis was that thinking can be studied experimentally. It described 30 studies, ranging from investigations of simple rule learning to the acquisition of complex concepts. Possibly more than any other book, this extensive work laid the foundations for the modern study of the psychology of thinking. One of the hallmarks of the cognitive approach and of Bruner et al.'s book is the idea that many behaviors are the result of thinking, and that thinking is far more than the network of stimulus and response associations that were assumed by many behaviorists. Cognitive psychologists from that era assumed that thinking involved the representation of external and internal events as internalized mental representations. There is no set, agreed upon definition of what a mental representation is, but for our purposes we should define a mental representation as a stable state of activation within a cognitive neural system that corresponds to an event, object, or idea. Birthday parties, cats, and vaccines are all things in the world. When I think about them, I generally do so in the same way each time. It is a stable representation. My representation for cats consists of memories and images of my own cat, knowledge about where cats come from, feelings of affection, and likely these are all activated when I think of cats. By this definition, then, thinking is the process by which these internal representations are manipulated. As a result, many of the cognitive accounts of that era emphasize the notion of symbolic processing. More contemporary accounts tend to rely less on the idea of mental symbols, and the advent of model cognitive neuroscience has allowed theorists to understand thought as a process of changing states of activation rather than purely symbolic processing. Indeed, many modern self help and motivational texts routinely refer to thinking and the brain, or how to help your brain make better decisions.